So in this lecture, we have done from question number 3.26 to question number 3.29. Okay, all of the questions are important in nature from a GW perspective. So it's better if you go through all of them once or at least once. Okay. So in this question, what was happening is there is a sphere. Okay. Inside that sphere, there is a charge Q1. So let me draw the question. There is a sphere, and inside this solid sphere, there is a charge Q1. The radius of this solid sphere is capital R. Now listen to me very carefully. Outside this sphere, okay, there is a cloud of charges. And the cloud of charges is given by the function of charge density is equals to alpha by R, where alpha is a constant. That means out here, outside the sphere, the cloud of charges will be distributed somewhat like this. At the surface of the sphere, the charge would be very prominent. Okay, and as I go farther from the sphere, the charge would decrease and decrease. Okay, as I go farther from the sphere, the charge would decrease and decrease. The question is asking find the distance x from the center of the sphere such that the electric field doesn't depend upon x. Okay, now let me think about the question. Okay, what does and when does the electric field does not depend upon the value of distance from the source? Think about infinite plate, okay, or infinite charge carrying plate. The electric field due to infinite charge carrying plate is nothing but sigma by epsilon naught, isn't it? Or rho by epsilon naught. Sorry, sigma by epsilon naught. What I'm trying to say is if the electric fields are parallel, okay, they do not depend upon the source, or they do not depend how far the point is from the source. Okay, so out here the electric field will look like parallel lines. Understood? So I got the diagram of the electric field. Now the question is how do I solve the question? Okay, let's analyze the question. Let's say point x. Okay, point x distance from the center of the charge. Okay, now can I use Gauss theorem? Gauss theorem. And what does Gauss theorem say? Electric flux is equals to electric field into area is equals to Q inside by epsilon naught. And how do I use this Gauss theorem? See, at point x, I would make an Gaussian flux, or sorry, Gaussian surface. Okay. Now I have to find out the area of this Gaussian surface and electric field. See, the objective that or the analogy, the protocol that I'm trying to follow is I'm trying to make an equation of electric field, parameters of charges and x. Okay, I'm trying to make an equation with electric field versus x. Okay, and somehow I'm trying to nullify the value of x manipulating the equation. So this question is solved using manipulation of equation, but somehow I have to make an equation of electric field versus x. Okay, and then somehow make the term of x disappear. That's my whole objective of this question. Okay, and let's see how do we do that. So electric field into 4 pi x square, and not only in this question, any question when such terms comes up, independent of x or independent of electric field or independent of y, make an equation of what is asked versus what is to be disappeared, and somehow manipulate the equation to disappear that variable. That's the entire thing. See, hard questions of physics are nothing but playing with equations. As long as you are comfortable to play with equations, every question is more or less simple. Okay. So electric field out here into surface of the Gaussian sphere. Surface of the Gaussian sphere is nothing but 4 pi x square, isn't it? Is equals to charge inside. What is the total charge inside? Charge inside is Q1 plus the charge on this cloud. No, out here up till out here there was a solid Q1 charge, and from out here the charge cloud or the cloud of charges follows this function, isn't it? So Q1 plus charge of cloud divided by epsilon naught. Fair and fine. Now the value of Q1 I know. I have to find out the value of charge of cloud. So what is the total charge that is inside this Gaussian sphere? Okay, Q1 plus this charge of cloud, isn't it? So this charge of cloud is inside the Gaussian sphere, and whatever is the charge outside this sphere or Gaussian sphere, that would not play part in the electric field, no? So simple enough. Now what I'll do is I'll try to find out the value of Q cloud or charge in cloud. See, if I look at the equation, okay, rho is equals to alpha by r, or charge density or volumetric charge density is equals to alpha by r. So how do I integrate a sphere? A sphere is integrated by taking thin shells, isn't it? So let me take a shell out here. Let me take a elemental shell out here. Okay, this elemental shell. Okay, yeah, this elemental shell, and this elemental shell is from radius r from the center, and the thickness of this elemental shell is dr. Okay, now what is the volume of the elemental shell? Volume of shell, or dv, or volume of shell, is equals to surface area of this elemental shell, or 4 pi r square into thickness. So volume of this elemental shell out here, volume of this elemental shell is nothing but 4 pi r square, or surface area of the shell, into thickness of the shell into dr. Now what is the charge inside the cloud? Charge inside the cloud is nothing but charge density into volume, isn't it? The charge density that is given in the question into volume, or volumetric charge density into volume, and I have to integrate this from which point to which point? From initial value is equals to capital R, sorry, initial value is equals to capital R, or radius of the smaller sphere, and final value is equals to x, or the point at which I have to find out the electric field. Okay, the initial value is the surface of smaller sphere which contains the charge q1, and the outer value or the upper value of the integral is nothing but x, or the total distance. Okay, so I got the limits of integral r and x. Now the things become simple. Q cloud is equals to, what is the value of rho? Rho is given by alpha by r, or alpha by r into, what is dv? dv is 4 pi r square dr. So r and r would get cancelled. So out here it would become alpha into 4 pi r dr. Now can I take alpha 4 pi outside because it is constant? Alpha into 4 pi is taken outside into r dr. Integration of r dr is nothing but r square by 2. Integration of r dr is r square by 2. And the limits of integral are smaller to x. I can do it via indefinite integral also by taking boundary condition. But let me just follow the simpler or shortcut method. Okay. Indefinite integrals are taken, or follow the steps of indefinite integral when the upper limit and lower limit are confusing. Okay. In the rest of the cases where the lower limits and upper limits are simple enough, just take direct integral. Both are the same thing. In direct integral, you put upper limit and lower limit. In indirect integrals, you put out the boundary condition. Okay. So out here, charge inside the cloud is equals to alpha 4 pi into x square by 2 minus r square by 2. This is the charge inside the cloud. Now, can I plug in this value or charge inside the cloud out here? So if I plug in the value, before plugging in the value, let me rectify the equation. Or electric field at point x is equals to q1 plus q2 divided by 4 pi x square epsilon naught. 4 pi x square epsilon naught. Not q2, q cloud. You can understand, no? Now simple enough. Let me just substitute the value of q cloud out here. Or E is equals to q1 plus, what is the value of q cloud? Alpha 4 pi x square by 2 minus r square by 2, isn't it? Divided by 4 pi x square, 4 pi x square epsilon naught. Okay, so I've got this equation of E versus x. Now somehow I have to make the parameter of x, or somehow I have to make the parameter of x nullified. Okay, and what are the conditions such that the parameter of x gets nullified? See, okay, what I'll try to do is I'll try to separate out the x. And how do I do that? See, E is equals to q1 by 4 pi epsilon naught, 4 pi x square epsilon naught plus alpha 4 pi by 4 pi x square epsilon naught into x square by 2 minus r square by 2. Okay, out here 4 pi and 4 pi would get cancelled, isn't it? 4 pi getting cancelled. Acha. Now if I separate out these terms, these two terms, what will happen? Alpha x square by c. If I separate out this term, entire term, okay, I'm writing out this entire term out here. Okay, this is nothing but alpha x square by x square epsilon naught minus alpha r square by x square epsilon naught. Acha, I forgot the 2 out here. So 2, 2. These 2 I forgot out here. Okay. So alpha x square by 2x square epsilon naught, 2x square epsilon naught, and alpha r square by 2x square epsilon naught. So out here in the first term, x square and x square would get cancelled. In the second term, is anything getting cancelled? No. So the entire term becomes alpha by 2 epsilon naught minus alpha r square by 2x square epsilon naught. So this entire term becomes how much? Alpha by 2 epsilon naught, alpha by 2 epsilon naught minus alpha r square by 2x square epsilon naught, 2x square epsilon naught. Simple enough. Okay. Now what I'll do is I'll separate the terms of x. Now let me clump together terms of x. What are the terms of x out here? X out here is nothing but this term and this term. So let me clump this term together. So E is equals to q1 by 4 pi x square epsilon naught minus alpha r square by 2x square epsilon naught plus alpha by 2 epsilon naught. Now what I'll try to do is I'll try to figure out, see, now in this question, okay, this value is already independent of x, this value out here, okay, this value is already independent of x. Now remaining these two values, okay, these two values, what are the conditions such that the variable of x gets disappeared? So if I say this entire two variable or the addition of these two variable or the congruent of means or the summation of these two variables, if it is equals to 0, then the entire thing or the entire electric field at point x only becomes this value. What I'm trying to say is if these two values become 0, okay, if these two values become 0 without the help of x square or with the help of x square, then I can easily say this value is independent of x. Okay, so for the electric field to be independent of x, these both terms should be equals to 0, isn't it? So I can say that q1 by 4 pi x square epsilon naught minus alpha r square by 2x square epsilon naught is equals to 0, isn't it? Because if these two terms become 0, okay, then this term is already independent of x, isn't it? So out here, if I send this entire term to the right hand side, it will become is equals to out here. Now let's play epsilon naught gets cut. Okay, 2 2s are 4. Out here, let's erase epsilon naught and 2 2 4. Okay, is there any pi? No. Let's make it 2. Okay, and x square would get cancelled. See, it's already independent of x. Okay, now let's see what is the condition. When q1 is equals to alpha r square, when q1 is equals to 2 pi alpha r square, okay, if q1 is equals to 2 pi alpha r square, what will happen? The electric field out here would become parallel. That means the electric field out here would be independent upon x. Okay, So when the value of q1 is equals to 2 pi alpha r square, when the value of q1 is equals to 2 pi alpha into r square, what happens? This entire both the terms become 0, isn't it? And if both the terms become 0, electric field becomes alpha by 2 epsilon naught. So the first part of the question is find the ball's charge at which the magnitude of electric field vector is independent of r outside the ball. That means the charge q1, so that electric field out here is independent of x. q1 is equals to this value. The second part of the question is how high is this electrical field? So electrical field when it is independent of x is equals to alpha by 2 epsilon naught. This entire both term becomes 0 and electric field is equals to alpha by 2 epsilon naught. Okay, but that's the question. And one more question. Okay, the electric field out here would look parallel to each other. So how was the electric field operating out here? Let me check. Okay, see, out here the electric field would be parallel to each other. But you must have heard, no, due to a concentric charge, electric field must be radial. So how is it becoming parallel? See, the charge out here is concentric, okay, and is a sphere. Fair enough. The electric field will be radial out here. But out here, the charges are not uniform out here, no. The charges are distributed by this function. So out here, when new charges are out here, some other point, so new charges will introduce electric field, isn't it? And if you look close enough, no, if you look close enough, that means if this distance is neglected, the electric field lines would look parallel. Okay. So in this question, what happens is there is a charge distribution or there is a charge of cloud. Okay. And the charge distribution is given by this function. Rho is equals to rho naught e to the power minus alpha r cube. So if I analyze this function, rho is equals to rho naught e to the power minus alpha r cube. This e to the power minus alpha r cube can be written as divided by e to the power alpha r cube, isn't it? Now if you analyze this function, as the values of r increases, okay, what happens? E to the power also r increases, and a finite number divided by a very large number is 0. Okay, so at very far away distance the charge distribution would be very less or nearly equals to 0, and at very lower values of r, that means r is nearly equals to 0, e to the power 0 is nothing but, or anything to the power 0 is nothing but 1. Okay, and any finite number divided by 1 is nothing but that finite number. So what we are getting out here is at the center we get a very large charge distribution or charge concentration, and as I go away from the center, okay, the charge distribution decreases, and this is a spherical cloud. Okay, that means out. Okay, let me draw the diagonal also. What I mean by spherical cloud is that means there is charge distribution coming towards you also and away from you also. That means there is a sphere of cloud. Okay, a 3D sphere of cloud out here. Fair and fine. Now the question is asking, suppose if I take distance r from the center, okay, or from the origin, or from where r is equals to 0. At r is equals to 0, it is considered to be origin. The question is asking find the electric field at this point, at distance r from the origin. So you have to find out the electric field out here. So how do we solve this kind of problem? By using Gauss theorem. Okay. And how do we solve Gauss theorem? We take an Gaussian surface. The Gaussian surface out here would be Gaussian sphere, isn't it? Because this is a uniform sphere, no? But the cloud is uniform. Okay. The cloud is not uniform, but the spherical distribution of the cloud is uniform. The charge concentration at the center is very maximum, and as I go away, what will happen? The charge concentration decreases and decreases. So I can say that the cloud is spherical in shape. Okay, so this is my Gaussian surface. Out here is my Gaussian surface. And what does Gauss law say? Gauss law, simple, electric field into area is equals to charge inside by epsilon naught, which is equals to electric flux. Now if I analyze this too, electric field at point r, okay, electric field at this point is equals to Gaussian surface, so into Gaussian surface out here 4 pi r square. is equals to Q inside by epsilon naught, or electric field out here is equals to Q inside by 4 pi r square epsilon naught. Fair and fine. We find out the answer. But we have a problem out here. The charge inside this sphere is not uniform, but given as a function of charge density or volumetric charge density. No? So how is a sphere integrated? A sphere is integrated in the form of thin shells. Thin shells integrated from 0 to r forms a sphere, isn't it? So if I integrate this shell, so Q in for Q inside. Q inside is equals to, how do I integrate a shell or how do I integrate a sphere? We take a elemental shell. Okay, take an element X or take the radius R. Okay, the thickness of the shell is dr. Okay, in order to avoid confusion, what I'll do is, if I take small r out here, I'll take capital R out here. Capital R is nothing but the distance from center to the point. Okay, so let me make this capital R in order to avoid confusion. This also capital R. Okay, capital R in the question also. Okay, so Q inside or charge inside this shell is nothing but charge density into volume, isn't it? Or charge inside is equals to, what is the charge density? Given by this function, rho naught e to the power minus alpha r cube. This is the charge density. Okay, into dv. What is the volume of this shell, or what is the volume of this elemental shell? The surface area of this elemental shell into thickness of this elemental shell. The surface area of this elemental shell is nothing but 4 pi r square and thickness is dr. So volume becomes 4 pi r square into dr, or surface area into thickness of the shell. And I have to integrate this shell from 0 or from the center to capital R, from 0 to capital R. Okay, fair and fine. Now if I solve this mathematically, I'll just do the mathematical portion quickly. See, out here, I'll just tell you how to do that. Okay, rho naught 4 pi r constant. Okay, that will come outside. Remaining will be e to the power minus alpha r cube into r squared dr. Fair and fine. Now if you assume, or integration by substitution, okay, assume minus alpha r cube is equals to t. Okay, is equals to t. Then minus 3 alpha r square into dr is equals to dt. Okay, so I'll just do the integration out here. So in this integration, or if I take all the constant term outside, rho into 4 pi, we are left with this term. Okay, now in this term I have assumed minus alpha r cube is equals to t, and then I differentiate this term. So dt by dr is equals to minus 3 alpha r square. So if I take this dr to the left hand side, it will become, see, it will become dr is equals to dt by this term at the denominator. Okay, now what I have to do is I have to substitute this value out here and dr out here. Okay, so if I do that, q inside, I just do it quickly. Okay, rho naught 4 pi 0 to r e to the power minus alpha r cube. E to the power minus alpha r cube is given by t. So e to the power t into r square. R square dr. Dr is given by dt by minus 3 alpha r square. Dt by minus 3 alpha r square. So r square and r square would get cancelled. Okay, this 3a or minus 3a would come outside. So minus 3a is coming, or 3 alpha is coming outside. So we are left with how much? E to the power t into dt. Let me write this close. E to the power t into dt. Integration of e to the power t into dt is nothing but e to the power t. Okay, integration of exponential is nothing but exponential only. So we are left with q inside. Q inside is equals to rho naught 4 pi into minus 3 alpha. Okay, this minus is written at the numerator out here, nothing different. Now t I have to substitute back. T is nothing but minus alpha r cube. So out here, let's substitute back the t. T is nothing but minus alpha r cube. What r cube? Small r cube. Small r cube. Okay, from 0 to r. So if I integrate it, q inside is equals to minus rho naught 4 pi by 3 alpha into e to the power minus alpha r cube minus, see, if I put 0 out here in place of r, this entire term would become 0, and e to the power 0 is nothing but 1, or anything to the power 0 is nothing but 1. So minus 1, fair and fine. Or q inside is equals to, now if I multiply this minus inside the bracket, it will become this positive term, or rho naught 4 pi by 3 alpha into 1 minus e to the power minus alpha r cube. Fair and fine. Okay. Now what the remaining part of the question is, this is the charge inside. So if I substitute this charge inside out here, what do I get? Electric field is equals to charge inside. Charge inside is nothing but this value, or rho naught 4 pi by 3 alpha into 1 minus e to the power minus alpha r cube, where capital R is the distance from the origin. Okay, divided by 4 pi r square epsilon naught, divided by 4 pi r square. Out here r is nothing but capital R square epsilon naught, because if I am taking the Gaussian sphere out here, this is the area of the Gaussian sphere, no, and Gaussian sphere is 4 pi capital R square. So out here, instead of small r square, we'll use capital R square. Okay, understood? Out here, instead of small r square, we'll use capital R square. Fair and fine. So 4 pi and this 4 pi would get cancelled. Okay, is there anything else getting cancelled? I don't think so. This 3 alpha would come at the denominator. So 3 alpha. Out here, let me write the rho naught neatly. Rho naught. Fair and fine. So this is our electric field at distance r from the origin. Okay, this is the value of our electric field at distance r from the origin. Fair and fine. Now the second part of the question is asking, find out the value of this electric field if the value of r is very large. Okay, if the value of r is considered to be infinite, and case number 2, when the value of r is to be very small. So I have to find out the value of this electric field, or I have to assume the value of electric field when r is very far away, first case, and when r is very near to the center, second case. Okay, now this was the electric field that we obtained in the equation. Okay, at distance r, the electric field would be given by this value. Fair and fine. Now part A of the question is asking when the electric field is much lesser than 1. So when this electric field is much lesser than 1. So this is part A, part 1 of the question, or AR cube is much lesser than 1. Okay, so in this electric field, or in this entire term, we just focus on this term. Okay, the remaining terms are more or less simple, isn't it? So if I focus on this term, what happens? E to the power minus alpha r cube. Okay, and this value of r nearly equals to 0. And in mathematics, we have a concept of binomial expansion, not binomial, binomial expansion. Okay, where if I expand e to the power minus x, it is nothing but 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus x4 by 4 factorial, and so on. That means when x is a very small number, you can expand the function like this. Okay, and we'll learn this in mathematics in class 11, binomial expansion. Similar kind of binomial expansion we did in gravitation. We have to assume the height to be very less. We did this binomial expansion, not this exactly this kind of binomial expansion. It was done by x by r. Remember those binomial expansion? So this is another formula for, not another formula, another function of binomial expansion. So we'll substitute, or we'll use this function out here. So minus x is very much lesser than 1. So what happens to the formula? When alpha r cube much lesser than 1, this becomes 1 minus alpha r cube plus alpha r cube whole square by 2 factorial. Okay, and so on. Now see, when the magnitude of x is much lesser than 1, if you square it, it will be much more lesser. If you cube it, it will be much more lesser. So we can ignore the higher terms out here, no? We ignore the higher order terms because they have so much lesser value, because they become insignificant because of the lack of magnitude. We ignore higher order terms. Higher order terms. They are insignificant because their magnitude is very less. Okay. Okay. Now, if I ignore all these functions, if I ignore the higher order terms, e to the power minus alpha r cube is equals to 1 minus alpha r cube. Fair and fine. Now, if I substitute this value out here, what do I get? E is equals to rho naught 1 minus 1 minus alpha r cube, okay, divided by 3 alpha r square rho naught epsilon naught, or E is equals to rho naught by 3 alpha r square epsilon naught. 1 and 1 would get cancelled, minus and minus would become plus. So alpha r cube. Okay, r square and r cube would get cancelled out here. Alpha and alpha would get cancelled. So we're left with alpha gets cancelled. R square and r cube gets cancelled. So we're left with electric field is equals to rho naught r by 3 epsilon naught. Case 2 or part 2 of the question. Part 2 of the question is nothing but when alpha r cube is much greater than 1. When alpha r cube is much greater than 1. See, so e to the power minus alpha r cube. When r is much greater than 1, what happens? See, e to the power minus alpha r cube can be written as e to the power alpha r cube. So if this r cube becomes of infinity, what happens out here? This denominator becomes a very large number, and any finite number divided by a very large number nearly tends to 0, isn't it? So this will nearly tends to 0. Okay, fair and fine. Or E is equals to rho naught by 3 alpha r square epsilon naught into 1 minus 0 out here. Okay, or E is equals to rho naught by 3 alpha r square epsilon naught. Okay, now you might have one more question out here. Okay, the question that you might have is, sir, if you make it 0 out here, or if you take minus alpha r cube to be very small, so you can assume r to be 0 and e to the power 0 is equals to 1. So you can directly write 1. No, why take the additional term out here? See, in some questions you have to take two terms. Okay, in other question you have to take the first digit of binomial expansion. See, if you assume r is equals to 0 or minus alpha r cube is equals to 0, you just have to take the first term of binomial expansion. Okay, but the answer in erodov is written in such a manner that you have to take the second term of binomial expansion. Understood? So it depends upon the question. Okay, whether to consider the second term or to ignore at the first term only. But if you consider out here, or if you assume this to be 0, this is nothing but the only the first term of binomial expansion. The remaining terms are ignored. Okay. In this question, okay, we have to find out the electrical field inside a charged sphere. Okay, but inside the sphere there is a cavity. That means there is a sphere. Okay, and this sphere is insulating sphere. How do I know? Charge is filled inside the volume of the sphere, and inside this sphere there is a cavity. Cavity means out here this much region is hollow. Okay, and we have to find out the electrical field inside the cavity. So let this be the center of the cavity. Let this be the center of the sphere. The distance between center of the sphere, okay, named as 1, and the center of the cavity named as 2 is given by a. Okay, so how do I solve this kind of problem? And you have seen this kind of problem in gravitation also, isn't it? Okay, so use the principle of superposition. Principle of superposition. What does principle of superposition say? It says that electrical field inside the cavity is nothing but electrical field due to the entire sphere at point 2. Okay, entire field sphere at point 2 minus electrical field due to cavity field sphere at point 2, isn't it? So let the electrical field due to the entire field sphere be E1 and the electrical field due to the cavity field sphere be E2. So E resultant or net electric field out here inside the center of the cavity is equals to E1 vector minus E2 vector. Now how do I find E1 vector? You can either use Coulomb's law or you can use Gauss law. If you use Coulomb's law, it's nothing but KQ inside by R square. If you use Gauss law, E into area, Gaussian surface area is equals to charge inside by epsilon. Okay, so we'll use Gauss law. Both are equally correct. And I have explained it a little bit before, no? Gauss law and Coulomb's are nothing but exact same replica of each other. Sometimes for Gaussian surface it becomes very complicated, so use Coulomb's law. Sometimes Coulomb's law becomes very lengthy, so use Gauss law. Both are the same thing, isn't it? So out here, if I use Gaussian surface out here, so the Gaussian surface out here would look somewhat like this. Okay. Suppose I'm generalizing it for radius r. Okay. I'll put the value of a, b, whatever is the value out here. I'll put it later. Suppose I'm generalizing for radius r. The thickness of the Gaussian cell is nothing but dr. So if I use Gauss law, electric flux is equals to electric field at that point into area. What is the surface or what is the surface area of this Gaussian surface? 4 pi r square. 4 pi r square is equals to q inside. What is charge inside? Charge inside is nothing but if there is volumetric charge density rho. If volumetric charge density rho is given, charge inside is nothing but rho into volume. And what is this much volume? What is the volume of this Gaussian volume? 4 by 3 pi r cube, isn't it? By epsilon naught. And if I solve this one, electric field is equals to how much? 4 and 4 would get cancelled. R square, R cube would get cancelled. And it would be sigma r by pi and pi would get cancelled. Sigma r by 3 epsilon naught, isn't it? Now if you observe properly, electric field or the direction of electric field is along the direction of radius vector. So if I plot a radius vector like this, the direction of electric field would be like this, isn't it? So electric field is equals to rho r vector by 3 epsilon. Understood this one? Now when I apply this E1 out here, E1 is equals to sigma r by 3 epsilon naught. What is the value of E2? The value of E2 or electric field due to this cavity at the center out here. If I apply this formula, R becomes 0 at the center, no? So this is nothing but 0, isn't it? So electric field or resultant of electric field is equals to 0. Okay. Now if you see the previous problem, okay, I found out the electric field at point A, but point O was at the center of the cavity. Okay. But what happens if I want to find out the electric field out here, or electric field out here, or electric field at any other point? What would happen? Or electric field out here? I would follow the same principle of superposition, isn't it? But let's say I want to find out the electric field inside the cavity only. Okay. So let me follow the principle of superposition. Let this be point 1. Let this be point 1 is nothing but the center of the largest sphere. Okay. Point 2 is nothing but the center of the cavity. And point 3 is nothing but a certain point at which we have to find out the electric field. Okay. So the net electric field at point 3 is nothing but electric field due to the largest sphere completely filled. Okay. Electric field due to the largest sphere minus electric field due to the cavity filled sphere at point 3. Okay. Now, what is the electric field due to a solid sphere? Yeah. Electric field is nothing but E is equals to sigma r vector by 3 epsilon naught, where r vector is nothing but the line or vector from center of the sphere to that point at which you have to find out the electrical field. So this r vector is nothing but the vector originating from the center of the sphere to the point where you have to find out the electrical field. Okay. So my first question is, what is the vector or what is the electric field due to this whole completed sphere at point 3? Is nothing but in this direction, no? In this direction. Okay. And the magnitude is how much? The magnitude is how much? Rho r r13. 13 is nothing but this radius vector. Okay, this radius vector. Okay, let me erase the a. A is nothing but radius vector from 1 to 2. This radius vector is a. Okay, 1 2 3 is nothing but r13. Rho 13 by 3 epsilon naught, isn't it? This is the electric field due to the completed sphere. Okay, what is the electric field due to the cavity field space? What is the electric field due to the cavity field space? R23. So it would be in this direction. Okay, and the electric field would be rho R23 by 3 epsilon naught. Okay, and what is the total electric field? Total electric field is nothing but this vector minus this vector, or this vector, or vector due to the completed sphere. Okay, or electric field vector due to the completed sphere minus of electric field vector due to the cavity. Okay, so if I see the diagram properly, a is nothing but the distance from center of the sphere to center of the cavity. 1 2. Okay, 3 is nothing but the point which you have to find out the electrical field. Okay, okay, and 2 is nothing but center of the cavity to center of the not center of the cavity to point which you have to find out the electric field. Now if you observe carefully, what is this vector? R13. What is this vector? R23. What is vector R13 minus vector R23? If you see very closely, vector 13, that means this vector minus this vector will be this vector or a vector. This is a, okay, this is equals to a vector. See, apply, you can apply any vectors now. Okay, since I have drawn a head to tail configuration, you can apply that triangle rule. Okay, okay. So R13 vector minus R23 vector is always a vector, isn't it? See, a plus R23 is equals to R13. So if you put the R1, or if you take the R23 to the left hand side, it will become this equation. Okay, and see, if I multiply all the sides, if I multiply left hand side and right hand side by rho 3 epsilon naught, R13 vector minus R23 vector, okay, is equals to rho a vector by 3 epsilon naught, isn't it? So what I can say is that, see, and if you further multiply or if you further divide them, rho by 3 epsilon naught R13 vector minus rho by 3 epsilon naught R23 vector is equals to rho a by 3 epsilon naught. Now what does this signify? What have I done out here? Okay, if you observe very closely, doesn't matter wherever inside the cavity you make the point. Okay, R13 vector minus R23 vector will always be a vector. Okay, doesn't matter of wherever you are inside the cavity. R13 vector. Okay, 1 is nothing but the center of the largest sphere. 3 is nothing but the point at which I am finding out the electric field. R13 vector minus R23 vector would always be a vector. Okay, so it doesn't matter wherever you are inside the cavity, the electric field will always be rho a by 3 epsilon naught. So inside the cavity, what I'm trying to say is, inside the cavity, okay, the electric vector is always rho a by 3 epsilon naught, and it is from the center of the largest pair to the center of the cavity. Okay, a vector is nothing but the vector from center of the largest sphere to center of the cavity, and it doesn't matter where in the cavity you are, because if you take, see, suppose I'm taking this point 3, r13 vector is nothing but this one. Okay, r23 vector is nothing but this one. Now if you apply it, means triangle law of addition of vectors, see, a plus r23 is equals to r13, and if you bring the r23 to the left hand side, we will get the same equation. Okay, if you take this as 0.3, they have the same value. Okay, that means the electric field or the summation of electric field or the subtraction of electric field will always result in rho a by 3 epsilon naught. Okay, so it doesn't matter wherever in the cavity you are, the electric field is always constant and has a value of rho a vector by 3 epsilon naught. Understood this concept? Okay, this is the same type of question, but instead of giving you a sphere, it is a long hollow cylinder. That means this is a cylinder. Okay, and this cylinder goes up to infinity, very long. Okay, and inside this cylinder there is a cylindrical cavity, and even this cavity goes up to infinity. Okay, where the distance between the axis of the cylinder and the cavity is equals to a. That means if this is the center of the cavity and if this is the center of the cylinder, the distance between the center and the cavity is equals to a. We have to find out the electric field inside the cavity or any point inside the cavity. So this was an orthogonal. Orthogonal means 3D perspective of the cylinder. So if I just take this cylinder and see it like this, the cylinder would form to be a circle, isn't it? So electric field at the center of cavity. Okay, distance between the center of cavity and the center of a cylinder is given by A. So if you apply principle of superposition, it's nothing but electric field due to the largest square or due to the whole cylinder, okay, minus electric field due to the cavity, okay, which is have the same answer. Okay, what is electric field due to a cylinder? Electric field due to a cylinder is nothing but, can use Gauss theorem. Okay, Gauss theorem means, suppose I'm taking this as a Gaussian surface, or let's find out the electric field due to a cylinder. This is a cylinder out here. Okay, this out here is a cylinder. That means the cylinder is in z axis. Okay, it will appear circle in this diagram. Well and fine. Now suppose I have to find out the electric field out here. So I have to draw a Gaussian surface. And how does a Gaussian surface of a cylinder look like? The cylinder only. Gaussian surface of a cylinder is nothing but cylinder. Remember the Gaussian surface due to a straight current carrying wire. A straight current carrying wire is nothing but a very small cylinder, no? Similarly, so the Gaussian surface of this is nothing but this Gaussian surface, and this Gaussian surface will go towards infinity and come towards infinity. Fair and fine. So if I look at this diagram in similar manner, okay, this is the thing. Got to find out the electric field out here. This is the Gaussian surface. Okay, volumetric charge density is given by rho. So if I use Gauss law is nothing but electric flux is equals to electric field out here, electric field out here. Okay, these are the same diagram from different perspective. Into Gaussian area. What is the Gaussian area out here? Suppose I'm taking this much charge or charge for each amount of height. Okay, the surface area would be 4 not 4 pi r, 2 pi 2 pi into this radius. Okay, the perimeter into height is the surface area of this Gaussian surface. So let this distance be a. Okay, 2 pi a or 2 pi r. Since I'm deriving a generic formula for cylinder, let this be r or let this be r. Instead of a, I'm writing r. I'll just substitute a later on. Okay, so 2 pi r into h is equals to q inside. What is q inside this? Or what is charge inside this Gaussian sphere or Gaussian not sphere, Gaussian cylinder? Volumetric charge density into volume of the cylinder, pi r square into h is the volume of the cylinder, pi epsilon naught. Now if I take these two values, okay, 2 pi would get cancelled, r and r square would get cancelled, h and h would get cancelled. So electric field should be equals to rho r by 2 epsilon naught, isn't it? Rho r by 2 epsilon naught, where r is the radial vector, isn't it? And e is the electric field vector. So the direction of electric field will be along the direction of radius vector. Fair and fine. So out here, this is nothing but a, and this is 0. Okay. So the total electric field due to E1 is equals to rho a vector by 2 epsilon naught. Out here, electric field vector due to 2 is equals to 0. Out here, the distance becomes 0, no? The distance becomes 0. So out here, E2 is equals to 0. So therefore, E resultant is equals to rho a vector by 2 epsilon naught, isn't it? Okay. See, what I did out here is my Gaussian surface became a cylinder. Remember the case, or remember how I used to take a Gaussian surface for infinitely long current carrying wire. Okay. Now if you zoom into the wire, it would be a cylinder, no? So same kind of concept is applied out here. Okay. Nothing different. This cylinder is nothing but zoomed out wire. Okay, and the Gaussian surface for a wire is same as Gaussian surface for a cylinder or infinite cylinder. Okay, if you zoom into a wire, it becomes an infinite cylinder, no? Fair and fine. And the concept that I talked about in the previous slide, that electric field at any point in this cavity will be same. That applies out here also. See if you look properly. Okay, if you subtract, means the electric field due to the sphere or electric field with the whole sphere from electric field to the cavity, the vector would be always this a vector. So it doesn't matter wherever in the cavity you are. Okay, the electric field vector would always be rho a by 2 epsilon naught. Out here I have taken at the center of the sphere. Okay, but in the previous slide I explained to you, doesn't matter where you take the point or where you take the point inside the cavity, the electric field at everywhere inside the cavity is rho a by 2 epsilon naught, isn't it? Because this vector, sorry, this vector minus this vector would always be a vector. Okay,